Hello everyone, this is Dr. G. Karthik Reddy working as Associate Professor in the Department of EC, MLR Institute of Technology, Hyderabad. Today's session topic is Cross Power Density Spectrum. In this session, we are going to discuss about average cross power spectral density, relationship between cross power spectral density and cross power, and the problem related to this concept. Okay, first, before discussing the problem related to this, first we will discuss the relationship between. Cross PSD. Cross PSD means you are having the relation, Sxy of omega. Sxy of omega is equal to, the integral minus infinity infinity r xy of tau e power minus j omega tau d omega. Or we can also write this as Sx yx of omega equal to integral minus infinity infinity or yx of tau e power minus j omega tau d omega. This is the formula related to the cross PSD. Next, we are having one more formula related to cross PSD. Cross PSD means here it is a dependent on the cross correlation function. If you know the cross correlation function, you can easily solve the cross power spectral density. Now next we are having one more formula, Sxy of omega is equal to limit t tends to infinity expectation of x star of omega yt of omega by 2t. This is the one more formula related to the cross power spectral density. Now next we are going to solve the relationship between cross power spectral density and cross power. Average cross power. For that, first we have to consider any signal whatever we are having, any random signal we are having. In this we are random signal is not defined, here it is defined only for certain interval. I am considering this as xt of t. Xt of t equal to x of t for the interval minus t to t, 0 otherwise. Same thing he has defined. Here similarly we are taking one more signal y of t, because we are discussing about cross, means two different process we are going to discuss. Similarly yt of t equal to y of t for the interval minus t to t, 0 otherwise. And here it must be satisfied the finite interval. That is why we are assuming minus t to t mod xt of t, which is finite. Similarly, integral minus t to t mod yt of t dt is less than infinity for all finite values of t. Now next, we know the relation in terms of time domain and frequency domain. Xt of t and xt of omega form a Fourier transform pair, and yt of t and yt of omega also form a Fourier transform pair. Next, cross power contain in xt of t and yt of t for the interval both either t, x of t and y of t. Both you are having the random signal which is defined over the interval minus t to t. Minus t to t. You are having the relation transformation between time domain and frequency domain. Now next, cross power obtained in x of t and y of t. First we are calculating the power only for the interval minus t to t. Minus t to t, to calculate that we have to take the help of Parseval's theorem. Parseval's theorem gives the relationship between energy in time domain and energy in frequency domain. This is the energy in time domain. First we are defining area under the power. Power is equal to energy by total time duration, that is 2t. 1 by 2t, this is a energy relation, integral minus infinity xt of t into yt of t into dt. Now xt of t into yt of t for integral minus infinity to, you can convert minus t to t, we have already defined here. Xt of t equal to x of t for the interval minus t to t, yt of t equal to y of t for the interval minus t to t. You change the limits, then what you are going to get this. Now next, xt of t equal to xt of omega, yt of t equal to yt of omega. Substitute that. We already simplified the similar procedure while we are calculating the relationship between power spectral density and average power. The same procedure we are following in this concept also. 1 by 2 pi integral minus infinity to infinity xt of omega into conjugate yt of omega by 2t. With the help of Parseval's theorem, we are having the relationship between this. Now next, whatever you are having, we are applying the average cross power. Average cross power we are taking for the total time interval for minus infinity to infinity. Okay, here we are considering t tends to infinity. T tends to infinity we are considering. Okay, now apply the expectation. Okay, Rxx of t1, expectation of xt of omega conjugate yt of omega conjugate by 2t into d omega. Then total average cross power in xt of t and yt of t. Okay, in xt of t and yt of t, 1 by 2 pi integral minus infinity to infinity limit t tends to infinity xt of expectation of xt of omega conjugate yt of omega by 2t into d omega. Okay, now next expectation. Okay, this is a formula related to the cross power spectral density. S xy of omega. This is the notation of cross power spectral density because we are using for two different processes. Okay, let x of t and y of t are two different random process. Okay, for that we are applying the cross PSD. S xy of omega is equal to limit t tends to infinity expectation of xt of omega conjugate yt of omega by 2t. Now next we are having the relation. Okay, now what is that relation? We already discussed that PSD and autocorrelation function. Okay, now here what is having? This is average cross power. Average cross power is equal to area under the curve of cross power spectral density. Cross power spectral density. Area under the curve of cross power spectral density is called cross power. Is called average cross power. Average cross power. Similarly, you can calculate for x of t, y of t plus tau we have calculated. Similarly, you can calculate y of t, x of t plus tau. Okay, y of t with respect to delayed version of x. Okay, that concept only here. Then the definition changes. Limit t tends to infinity expectation of yt of omega conjugate into xt of omega by 2t. By 2t. Next, pyx is equal to 1 by 2 pi. Okay, same. In place of xy, you are having yx. 1 by 2 pi integral minus infinity to infinity. In place of sxy, you are having syx of omega d omega. Okay. Then what you are having both relation. Okay, both the relation when you compare it. When you apply the conjugate to this, then you will get pyx. Okay, pyx. Then total cross power is equal to pxy plus pyx. Okay, when they are orthogonal to each other, the resultant will be equal to 0. When they are orthogonal to each other, the resultant will be, both will be same, then the resultant will be 0. Okay, this is the relation between average cross power and cross power spectral density. Okay, the average cross power and cross power spectral density, this is a relation. Okay, we have to know the summary points. Important points to remember is S xy of omega. Okay, first Rxy of tau is a Fourier transform pair. S xy of omega integral minus infinity to infinity Rxy of tau e power minus j omega tau d tau. Now next, inverse Fourier transform is also applicable, which is equal to 1 by 2 pi integral minus infinity to infinity plus xy of omega e power j omega tau d omega. Okay, these two are the important relationships we are using for the relationship between cross correlation function. Rxy of tau represents cross correlation function. Sxy of omega represents cross power spectral density. And one more second definition. This is the first definition of cross power spectral density. Second definition of cross power spectral density is Sxy of omega is equal to limit t tends to infinity 1 by 2t expectation of xt of omega into y star of omega, or we can also use this as, okay, for example, if you are considering as xy, you consider this as x star. Next, syx of omega is equal to limit t tends to infinity 1 by 2t expectation of xt of omega yt conjugate of omega. Okay, these are the two relations we have to follow for understanding the concept of cross power spectral density. For cross power spectral density, you can use any one approach for solving the problem related to the cross power spectral density. Cross power spectral density is always applicable only when you are considering two different random process, that you are considering x of t and y of t, and the first definition compulsory, you require the input as cross correlation function, that is rxy of tau. These are the topics related to this session. In this session, we have discussed the relationship between cross power spectral density and cross power. Cross power represents what? Area under the curve of power spectral density is called cross power. Thank you.